Hi, hello engineers, and welcome back to the DevSecOps series. So, today we are going to learn everything about what you are supposed to introduce in the security stuff for your CI/CD. And there are a lot of different tools that you guys might have used, right? Jenkins, Argo CD, GitLab CI, GitHub Actions, everything. So how do we secure those particular stuffs? That's what basically we are going to learn. And the CI/CD is not just adding some one or two tools to your pipelines. It is to consider CI/CD as a whole that is going to be responsible for your repositories. I mean the place where you hold or host your code base, and then you trigger some build procedures, you use some Docker images to build your application on top of it, and then you kind of you know have certain API keys or credentials for AWS secrets, let's say, and then they are consumed to be deployed on AWS infrastructure, so to say. So those things we are going to learn in our today's topics. How do we secure all of them? And basically you can see over here repositories, pipelines, secrets, builds, artifacts, deployment, supply chain. That is all what we can consider as a part of CI/CD. So without uh, you know giving too much thought to these things, let's see what is CI/CD is the very first important thing that we are going to learn. Then the difference between delivery versus deployment I mean it is basically a part of DevOps topics, but you know until you have the entire understanding of what CI/CD is and what is difference between these things and what are the different stages, uh, you don't really would get how to integrate security in that stuff. So then why CI/CD is important? Then CI/CD security best practices and popular CI/CD tools that we are going to learn today. So next is what is CI/CD first of all. So there are two stuff to it. CI is integration and CD is either deployment or delivery. So first of all, let's see what those things combined would do for us. So CI/CD aims to streamline and accelerate the software development lifecycle. So whatever the I mean, let's take an example. There is a development that is going on for one particular application. So not a single person can develop entire feat of functionality for an application. So there are different teams that are working on different parts or functionalities of an application. So now, once these teams build their code, I mean, write their code and build it in a particular tech stack, then they want to push it somewhere, so that they could merge all the changes of all the developers and then create a single, application out of it. So that is what we are doing, is integrating all of the codes of the developers that they have written on a single, repository. So that's what we call as integration. Integration of what? Integration of the different code snippets that are being written for different functionality for your application. That's one thing. Then what is CD? Continuous deployment. So once you have integrated all of this particular code from your developers, now you need to build and deploy this particular application. Build it means to get all the code, then check if it is properly integrated with the different components of your application, and then create a executable file or a Docker image out of that particular code base and then run it on a machine. So that comes under the deployment phase, wherein you would build the code. I mean, integration is, I mean, building is also part of the integration phase, wherein once you commit the code, you would test the build. If it is not failing, then only you would integrate your code base. So CI refers to the practice of automatically and frequently integrating code changes into a shared source code repository. So a source code repository for all of the code for the application. Then whatever the frequent changes the developers are making, they should be integrated in that particular code base. So that is what comes under integration phase. And CD is the process that refers to the integration, testing, and delivery of code changes. So Delivery, it means to publish this particular your application using the source code, and then after creating the binaries to a particular platform. So that comes under, I mean, you first go through these different phases. Oh, sorry, I forgot to dock myself over here. Yep. So you integrated the test code, I mean, integrated the code, then tested it, and then deployed it on somewhere. So that's what we can see in this particular CI/CD. I mean, I'm assuming that you are a DevOps engineer. That's why you landed on a security stuff for CI/CD. Okay, that's a pre-assumption that I have made. So don't worry if my explanation sounds like it is something of much higher level than you could grasp. So that's a pre-thought. You need to know DevOps before you get into DevSecOps. That's the basic given. So delivery versus deployment, what's the difference between them? So continuous delivery and continuous deployment. So let's talk about delivery first. So ensure that code is always deployable, in a deployable state and ready for production, after passing automated test, but requires a manual approval step for deployment. Now, there are different branches. Like, you release one version of an software, okay, and then you have to modify it, add some functionality, add some features, and then release another version of this application. Then again you decide to release a third version of this application. So now, before releasing the application or the code base to customers, what we need to do is to make sure that whatever the code I have, it is properly built, it is properly tested, and then it is in a deployable state, so that whenever I want to release, let's say I want to release it on October 10, okay, then it should be in a deployable state, so that I could, I mean, before that also, okay, before that on October 5 or October 2, I would test this code if it is deployable or not. And once I have finished checking, I mean, having these pre-checks, okay, we want to make it ready for production, so that we could pass some, I mean, we could test it using some automated tests, right? So once that is done, I would only deploy it on 10th October. Okay. After making sure that my code is deployable, everything is working fine, I would deploy it on a dummy environment or a test environment and check it. Everything looks good. Then only I would hold up to the release date, and then only I would deploy it. So that is what it needs, a manual approval from our end and when to deploy that thing. So that is a one stuff that we need to take care of. So once we have these things ready, then comes the deployment stuff. Okay. Now, deployment, CD, continuous deployment, it is an extension of continuous delivery. Okay, it is doing the same things, keeping your code ready, making sure it builds properly, nothing fails, and it is in a deployable state with the entire infrastructure ready. Now, continuous deployment will automatically deploy every successfully tested change to production without human intervention. So now, you do not want to hold up to the release date. You want to instantly deploy all the changes that are tested and passed successfully. So that comes under continuous deployment, which is, you do not need an human intervention, human intervention, and it would come continuously deploy your stuff on the production environment. So that's basically, I mean, ROCD is majorly used for that particular purpose. So continuous delivery requires manual intervention and release on a certain date or certain timeline period that have been decided. Even you can do it today itself, but it would require your approval to do so. And then continuous deployment is to without any human intervention, you can do this, that particular thing. So I hope that was a bit clear for you guys. And then next is the key difference is the automated versus manual step for releasing to the live environment. With delivery providing more control. Okay, so if you want more control on your deployments, you need the continuous delivery option, and then deployment enabling faster and more frequent releases. Now, if developers are, I mean, when to use what? So whenever you are going to deploy a manual, sorry, not manual, a major release of your application, then only you would go for the delivery purpose, continuous delivery. For deployment, you can consider is it as faster stuff to check your changes in the live environment. So if some developers made any changes and he want to check it how it works on the live environment, then what would happen, he would directly go for continuous deployment, and then he would be able to check it instantly on the live environment, so that all the changes are done successfully. So you can bifurcate both of these things. So now there are many organizations who opt out for continuous deployment because uh, only successful builds would be deployed, not the failed one. So they give you more time to market. Less time to market. You could deploy frequently on these particular, whole whole systems. Uh, Great. So, what are the different stages in CI/CD? So, first, the developers push their code in the Git repository or wherever you are hosting, GitHub, GitLab, Bitbucket, anything. Then you would try to check if the code that the changes in the code that are made are properly built together. Then you would test these things, nothing fails, everything passes successfully. Then you would go for a release freeze. A particular branch would be considered as a release branch, which you have to deploy it on the infrastructure. Then you would deploy it to the cloud infrastructure or whatever on-premises infrastructure that you have built, and then you would go for the operation state, wherein you would check for the site reliability stuff, if the application is working fine, if the services that it is consuming are not overwhelmed by different requests, and the load balancing is working fine, and all these things are doing great. The routers, the routing step is good, and all those stuff. So that comes under the operate stuff. And then finally, once you do all these things, you also keep monitoring these things. As I mentioned, the load balancer is working fine, if the routing is working properly, if nothing is going down. Let's say some application is trying to consume a lot of memory, then you need to set up certain alerts or logs on which system is taking up the resources and what is failing. So that comes under monitoring stuff. So Prometheus, Grafana, ELK stack, a lot of different things that you can do for monitoring stuff, right? So that's basically about monitoring. And then why securing CI/CD is important? Because it is a part of supply chain. Supply chain of what? From code to environment. So there could be a lot of possible attacks on that particular supply chain. And if certain stuff goes down, there would be, you would be in a big trouble to deploy other things in that case. So, securing CI/CD is important because it is a high value target. Now, compromised CI/CD pipelines are a major target for attackers these days because enabling them to inject malicious code, steal data, or gain access to production system. Because you are using runners. Let's say you have a Docker image, and what happens basically in CI or CD? You pull a Docker image from open source and then add your code in it, and then it is built in another Docker image, and then it is deployed. Now in doing that, if someone tampered with the Docker image which is being pulled from the source, and then it is being pulled into your runners, let's say. Now once one malicious code which comes with that particular Docker image, if it lands on your runner machine, you know then it could either execute itself, or if you give the Docker command, the Docker run stuff to that image, and it inherently in the back of it runs an executable file or a shell script that would create a reverse shell to a particular given IP address. So what will happen now? The host, the runner host of your CI/CD pipeline configuration would be, the access to it would be given to someone, another person who is, the endpoint of the reverse shell. So if you know reverse shell how it works, then you would get the criticality of this particular uh, stuff, or like how someone could steal data or gain access to your production environment by using the runners that you have configured. So that's why it is a high value target, and it comes under supply chain attacks. Okay, if you have heard about this particular name, supply chain stuff. Okay, so then next comes the early detection. By embedding security into the pipeline, organizations can detect and fix vulnerabilities earlier, reducing the risk of them propagating into the production. So now, once you have enabled SAST, SCA, DAST, IAC scanning, then secret detection, and what else? Container or image scanning, not container scanning, image scanning. Then you would get to know. Okay, now I have a lot of things placed, also artifact signing and then verifying them. If these things are in place, you would detect early in the CI/CD process, wherein you can check for uh, issues or vulnerabilities as such. Also, the access part for the repositories, you need to lock your repositories, organize them into groups and organizations, as well as different project, so that you could only give access to the people who are really working on those projects, like to not let other people's access it accidentally and then expose your intellectual property to somebody else. So that is what early detection is all about. So compliance, a secure CI/CD pipeline helps organizations meet security and compliance standards throughout the software delivery process, which would make you easily certify for NIST CSA, for SOC 2 compliant stuff, or anything else that is you are uh, adhering to. I mean, your industry is adhering to. So those are the few things that you can check for compliance purpose. So a lot of things are there: GDPR, ISO 27001, uh, SANS, COVID, not COVID, sorry, uh, the NIST CSF, the FedRAMP, FIPS compliance and regulations, a lot of things. So we will look after it in our next videos. I mean, hopefully when the compliance sections would come. Until then, we would be learning this stuff. Okay, CI/CD. I mean, now we will talk about CI/CD best practices. So the secure CI/CD tools. Um I mean, whatever the tools that you are using should be secure first of all for CI/CD purpose. Okay, either it be Jenkins, GitLab, Circle CI, Drone CI, anything. Okay, so restrict access to the tools like Jenkins, GitLab, Circle CI, Drone CI, GitHub, and then regularly update the tools and then patch the CI/CD tools, so that you if there are any errors found out in certain version, then it would be not much affecting to your platform where it is being hosted. So credential management needs to be done. You need to store your secrets in secure vaults, either HashiCorp Vault, AWS Secret Manager, and never hardcode secrets in pipeline or repositories. So you need a lot of different tokens, API tokens, security tokens, secrets that would give you access to your different environments, and now you are deploying your code on that particular environment. So you need to make sure that you never hard code them, so that it is not exposed to the external world. If you accidentally hard exposed these things, then something would be seriously damaged on the cost side of your what we say, for you maybe. So there was one email I read on LinkedIn for one particular person who kind of was creating an open source project. He had a publicly hosted repository on GitHub, and then it was consuming some of AWS services. And then because he used AWS services, he had some certain secrets for AWS which were there in the repository, somewhere being used as variables. Now, once some malicious actor found it in the open source, and then he used those secret to deploy certain, I mean, use that particular resources. And then this person who was having, I mean, a college student who was using this thing got a bill of $25,000 or something more or less. I don't remember exactly the number, but $25,000 of bill, AWS bill for a person who is not even earning something is really a huge cost for him. It is a major setback because how, I mean, there are yearly salaries of people who $25,000. So uh, that's what you could majorly go wrong if your secrets are found in your repository. So that could be misused. Next is code repository security. Enforce sign commits and code reviews, and you should need to know who committed what so that you could audit it, and then you can trace out if there are certain errors found out after the code has been merged and deployed. Use branch protection and enforce CI checks before merges. Okay, so checking who is committing, what it is being committed, what changes are being made by each commit. That is what you need to check. Then pipeline hardening. uh, Run pipelines with the least privileges. As I told you, then isolate build environments using containers or ephemeral runners, and avoid running untrusted code directly. So as I mentioned, the environment, the build environments that you are using, the pipeline that you are using, uh, the runners that you are using could be at risk somehow. So in order to avoid it, you need to do pipeline hardening. And then, we are just right now discussing the theory part, because until and unless, like, there are different 20, not 20, 30 to 35 components that we need to discuss in our DevSecOps series, because until and unless you learn the entire concepts, you would not eventually get the practical stuff. So that's why I kind of right now is focusing, I am focusing on the theoretical part, uh, and we'll soon see the dev, I mean, the hands-on stuff later on. So now, dependency scanning, you need to scan your dependencies that you are consuming, because there are different vulnerabilities in the open source tools or whatever the packages that you would consume, and then use software composition analysis tools so that you could make sure that whatever uh, open source stuff you are fetching is a bit safe, so to say. Then artifact integrity, sign the build artifacts and verify signatures during deployment, because if someone tampered with your uh, artifact that was created after the building of your code, and then you have a storage for artifacts somewhere, either S3 or artifactory, whatever you use, and then someone tampered with it, you would not know what artifact is being deployed. So you need to verify the signatures during the deployment phase for this thing. Then use a secure artifactory repository like JFrog Artifactory, GitHub packages, and all this stuff, so that the artifacts could not be tampered. Then infrastructure as code security, as I told you, IIC scanning should be done. IIC templates, Terraform, CloudFormation are for misconfigurations, and use tools like Checkovi, TFSec, and AWS config. This is to be done in your CI/CD, because before creating an infrastructure, you need to check either it is configured properly or not. Once you allow what we say public access to your security groups, using security groups to your EC2 instances, someone could log into it. If you mistakenly provided the shell config, sorry, SSH option is allowed or enabled for internet, the 000.0.0.0/0 stuff, then that is a serious misconfiguration, and someone could log into your AWS accounts or AWS, the EC2 instance, and then do something crypto mining stuff, and then they could be used for that purpose, and you would be billed inappropriately. And then it is a financial risk. Someone is using the instances for free that you have created because of your misconfiguration. That is why you need to run your ISS codes through something for like Checkovi, TFSec, or AWS config. We will see I think we have seen IAC and CM configurations. So I will link this video over here so that you could go and check what things we can do for IAC security. Then audit logging, you need to enable detailed logs for all CI/CD stages and written logs for forensics and compliance, because you need to know if something goes wrong, where it goes wrong. Okay, because I mean investigation is a part of that thing, but if you have enabled logs and they are stored securely somewhere, you would get very easily what things you need to now check to fix this stuff. Then security gates in pipeline integrate SAST, dynamics security scans for your pipeline, and then only check if there are any critical vulnerabilities found in the application using these different scans, SAST and DAST. I will link all the videos over here or drop down in the comment section, not comment section, sorry, the description section. And then you could check what critical vulnerabilities are found out in your code or your application as such. And then if there are any, then you could block the commit, I mean, block the deployment process. If there is everything good, you can see it would be passed. So then use zero trust principles. Don't trust any component by default. Always verify identities and code signature. That is a given. Zero trust architecture is what we will be also learning in our next videos. I mean, zero trust basically means do not trust anything, not even your family members, until and unless they provide a identity or they provide any signatures, code signatures, and then only allow them to enter your home. So that's what. So popular CI/CD tools. I mean, it's a bit hot today over here. Popular CI/CD tools are GitLab CI/CD, GitHub Actions, Jenkins, Bamboo, TeamCity, DevOps, Azure DevOps, Spinnaker, Circle CI, Argo CD, and these tools. I mean, sorry for my face over here. So these are the different tools that you can see in the market, which are popularly used for CI/CD purpose. And then how to secure all of them is up to you. Okay, you need to decide. Your security team would be coming up and deciding what things are supposed to be secured on what phases. So that's it for the CI/CD stuff. I think it was a short, not short, a pretty big lecture on CI/CD security without any uh, uh, what we say demo. But I hope you got the point. Why CI/CD is important? What is CI/CD, as well as different best practices that you can adopt for your entire pipeline and CI/CD configuration security. So great, we have covered CI/CD security now. Secret management is done. ID plugins is what we will see maybe in the next videos. MAST is done. SBOM is remaining. Container security is remaining. Okay, I think all of these things, DAST, IAC and CM, IST is done. RASP is done. WAF is remaining, and these stuff are remaining. So in the next one, we will see something good stuff. I don't know if we would. I mean, I have not made any PPT as of yet, as of now. So we will either see SBOM or image or container security. So maybe we will go for image security in the next topic. I'll need to refer to the first video that we have created in terms of the topics, and then we will go ahead. So that's all for today's CI/CD security topic. Let me know if you have any comments, you have any questions or any thoughts on this CI/CD security stuff, or if you are doing it or if you are working it actively, you can check what kind of security measures your organization is taking in your CI/CD, because every DevOps engineer somehow works on it, and you should know what things are to be secured, okay, and how to secure them. That's it for our today's video. Keep learning till then. I mean, we will meet in the next video and keep learning till then. Bye, guys.